How VFDs work explained simply. Opening scene, animation of a motor running. Narration: have you ever wondered how we control the speed of big motors without wasting tons of energy? The answer is VFDs, variable frequency drives. In this video, let's break down how they actually work, simply and clearly. Cut to title screen, VFD, variable frequency drive working explained. Part 1. What is a VFD? Narration: a VFD is an electronic device that controls the speed and torque of an electric motor by changing the frequency and voltage supplied to it. Show: animation of a motor speeding up and slowing down smoothly. Narration: normally, motors run at a constant speed based on the frequency of the power supply, like 50 Hz or 60 Hz. But what if we want to run it slower, or faster? That's where a VFD comes in. Part 2, Basic Working Principle. Narration: a VFD works in three main steps: rectification, DC bus, and inversion. Show: flowchart, AC input rectifier DC bus inverter motor. 1. Rectifier stage. First, it converts incoming AC power into DC using a rectifier made of diodes. 2. DC bus stage. Next, it smoothens the DC voltage using capacitors. This clean DC voltage is stored temporarily in what's called the DC bus. 3. Inverter stage. Finally, the inverter converts the DC back into AC, but now at any frequency we want. It does this using power electronics like IGBTs, switching the voltage very fast. Show: animation of AC turning into DC and back into AC. Part 3, Controlling frequency equals controlling speed. Narration: by adjusting the frequency of the output AC, we can control the speed of the motor. Higher frequency equals motor spins faster. Lower frequency equals motor spins slower. Show: graph of frequency versus motor speed. Part 4, Why use a VFD? Narration: VFDs are everywhere, from pumps, fans, conveyors, elevators, and even big machines in factories. They save energy, reduce mechanical stress, and give us precise control over motor speed. Show: real-world clips of VFDs used in industry. Part 5, Conclusion. Narration: so in short, a VFD takes in AC power, converts it to DC, processes it, and sends it back out as a custom AC signal to control motor speed exactly the way we want. Closing shot, recap animation. Narration: simple, right? If you liked this explanation, don't forget to like, subscribe, and comment below with any questions you have. End screen, subscribe button, more videos. Converts AC, alternating current, to DC, direct current. 2. DC bus, DC link, filters and stores the DC power, uses capacitors and sometimes inductors. 3. Inverter, converts DC back to controlled AC with variable frequency and voltage, uses IGBTs or MOSFETs. 4. Control circuit, controller, brain of the VFD, manages speed, torque, protection, etc., uses microprocessors or DSPs. 5. Cooling system, fans, heat sinks, or liquid cooling to prevent overheating. 6. Input filter, EMI filter, reduces electrical noise going back to the supply. 7. Output filter, protects the motor from voltage spikes and reduces harmonics. 8. Braking unit, optional, dissipates excess energy during motor deceleration. 9. Display, keypad, for programming.